Okay.
Okay, and
Now start presenting. Yes.
So you see, yes.
yes, absolutely okay.
So I represent um, thesis on the topic increasing of the cryptographic strength of set encryption by ensuring the transformation quality of the information block. Um It consists of analyzing the symmetry of crypto transformation and approaches to algorithm classification to overcoming the contradictions between the quality of the information block transformation and the statistical characteristics of the encryption results, and analyzing the length of the key and the way of its possible increase. The actuality of the work is in such statements as, firstly, the use of low-resource cryptography makes it possible to implement information protection in case of technical resource storage. Secondly, the need of the implementation of low-resource cryptography is constantly increasing and affects an expanding range of human activity areas. Thirdly, a significant need in the development of low-resource cryptography is related to a significant increase in the number of local conflicts and an increased military confrontation between states. Um, so the definition of such operation describes an operation related to the theory of cryptographical encoding. Set operation itself is a enumerated combination of elementary functions, and each elementary function creates outcome and sequantum of information based on the processing of the incoming sequanta. So on its own, a single sequantum is defined as a minimal amount of information which functions within such operations, and depending on the intended usage in set operations, so this sequanta can exist as a single bit of a byte, a word, or two words, etc. On the next slide, you can see the main methods of using additional encryption and evaluating the quality. This table presents conditional low resource block cipher algorithm that convert blocks of information by n bits depending on k bit key. So let's denote the operation of direct cryptographic transformation as you can see on the slide. And then the crypto transformation operation will be symmetric if the condition E is equal to J. And if E is not equal to J, then the crypto transformation operation will be asymmetric. These definitions are based on the fact that each row of the table represents one of the permutation variants in the fields of G. On the next slide, you can see the cryptographic trends, which directly depends on the quality of information block conversion. In general, the quality of the conversion is defined as, you can see the formula, where Q is the value of the quality of converting the eth block of information by this G's key defined on the else quality identifier. So let's consider Q as the minimum acceptable values of quality indicators for Q, and the method of its determination you can see on the slide. So the cryptographic algorithm will partially meet the requirements of the cryptographic transformation quality if the set of quality indicators contain indicators which acceptable and unacceptable values. So the main methods of using additional XOR encryption and their quality evaluation are divided into three parts. First of all, additional XOR ciphering of the data block. Secondly, additional XOR ciphering of encryption results. And thirdly, additional XOR ciphering of the key sequence. Other variants of applying of the additional XOR ciphering are based on a combination of the plain variants already listed, and based on the variance analysis of additional XOR ciphering, only the XOR ciphering of the key sequence ensures the lookup table's modification without decreasing the quality of the encryption results, and as a result provides effective counteraction to statistical cryptanalysis. If a crypto algorithm implements a group of cryptographic transformation, encryption is carried out by the key M and decryption by the key P. Since in this case there is one encryption algorithm, then depending on the increase in complexity of F, crypto algorithm can be classified into symmetric, conditionally symmetric, conditionally asymmetric, asymmetric, and absolutely asymmetric. The strength of the crypto algorithm with absolute and limited public keys will be the same, since the attacker doesn't know the available limited group of keys and transitions between key for direct and inverse transformations. So it should be noted that the number of substitution variants doesn't depend on the information block being encrypted. Based on this, the number of variants for encrypting information with determined of the keys variants will be found as s to the power of n. The tabular representation of the block ciphering conditional algorithm has a set of key which includes 2 to the power of key variants. In comparing the theoretical set and the practical set of key that can provide the qualitative encryption, let be 2 to the power of k equal to the s to the power of n, then it can be argued that the crypto algorithm has the correct length of the key, which allows maximum use of its capabilities, which providing the quality encryption. And if 2 to the power of k is less than s to the power of n, then the crypto algorithm has a short length of the key, which allows providing the qualitative encryption but reduces its cryptographic strength. For this case, in the table 2 is provided an extended tabular representation of a block ciphering conditional algorithm. And if 2 to the power of k is more than s to the power of n, then the crypto algorithm has a length of key which leads to the one of two cases. The one case, the algorithm doesn't provide qualitative encryption, but it is more resistant against the brute force attacks. And second case is the algorithm provides a qualitative encryption, but during its implementation, the key length will be reduced. And on the next slide, you can see an extended tabular representation of block ciphering conditional algorithm, which was mentioned before. The analysis of the block ciphering conditional algorithm when using an additional source ciphering to detect the correctness of determining the shared key required to encrypt one block of information. The additional source ciphering for the data block and the additional source ciphering the encryption results leads to deterioration in the encryption quality, since the aggregate encryption itself will partially meet the requirements for the crypto transformation quality. The losses in encryption quality will be offset by an increase of the number of keys. Given in the table 2 increase in the number of keys till 2 to the power of n can only be achieved by using all lookup tables directly. And an alternative way to improve the algorithm of qualitative encryption based on applying the indicators of crypto transformations quality is to use a random sample of one of the block variants for qualitative substitution instead of the input block of information. Since S is less than k, then this leads to a decrease in the length of the additional necessary for transforming the information block, since the number of keys bits in the tabular algorithm will be less than the number of bits needed to ensure any qualitative substitution from the admissible substitutions. and analyzing the length of the key and the way of its possible increase, it can be argued that the proposed algorithm of encryption will provide given conversion quality in the information block, and there are three cases. In one case, if 2 to the power of k is more than s to the power of n, then it can be argued that the crypt algorithm doesn't provide a qualitative transformation in the information block, or the length of the key is not correctly determined, or several keys implement the equal crypto transformation of the information block. As it has already been noted, if the crypto algorithm partially meets or doesn't meet the requirements for the quality of the cryptographic transformation, then it will have the maximum number of keys to transform a block information, and this number of transformations is defined as 2 to the power of n. In the case of improving this algorithm by applying a random sample of any possible substitution, by analogy with improving the algorithm for qualitative tabular encryption, then the number of allowable substitutions will be determined as 2 to the power of n. So, in the work, a tabular representation of a conditional Lorenz algorithm of block encryption made it possible to study the conditions for the correctness of its application. The obtained results provide the possibility to detail the classification of a cryptographic algorithm based on the processes of direct and inverse transformation, as well as the keys for direct and inverse transformation of information. The causes of apparent contradiction between the quality of the information blocks transformation and the statistical characteristics of the encryption results are considered. The ways to overcome the contradiction are defined and analyzed, and a conclusion is made about the effectiveness of implementing the additional XOR ciphering of the key sequence or pseudo-random changes in the encryption algorithm. The possibility to increase the key of the block ciphering conditional algorithm using additional XOR ciphering in the process of cryptographic transformation is studied, and its effectiveness was evaluated. Alternative ways of increasing the cryptographic strengths of cryptographic algorithms on the basis of key management are considered. And the next stages of research can be cover the development of set operations models to implement the obtained results. And in the future, it is planned to implement the transition from discrete operations models to their architectures, and from the architectures to lower resource encryption technologies. Thank you for your attention.
Thank you very much for your very interesting report. Dear colleagues, have you any questions to reporter?
I have one question, if it's possible.
Yes, please.
My question is the following. What about any quantitative assessment of improving characteristics which you described in your research? Quantitative assessment.
Estimate.
The quantitative assessment is in that in three cases. If 2 to the power of k is equal to the s to the power of n, if it is less, and if it is more than s to the power of n. And it leads to three different results. In the first case, the crypto algorithm has the correct length of the key. In the second case, the crypto algorithm has a short length of the key, and the third case, it leads to two different cases. It's in the first case, it doesn't provide qualitative encryption, and in the second case, the algorithm provides qualitative encryption.
Dear colleagues, have you any more questions?
Thank you.
So I have
I
Sorry,
have
please, please.
oh, sorry.
Please.
I have small question. Did you compare your approach with other?
Yes, we have compared our approach, and we got to know that our approach is more effective than existing approaches, and its efficiency is considered.
Thank you.
Please, once more questions. I have one question, two questions. First of all, how to estimate the quality of transformations? And second, how to compare quality of different methods?
We estimated quality. We compared different methods of using additional XOR encryption, and we evaluated their quality. It's represented on the table where a set of keys variants and a set of data blocks variants are represented. So the operations of direct cryptographic transformation as an operation of its inverse transformation were considered, and the crypto transformation operation will be symmetric if the condition E is equal to G. And these definitions, which we were considered, are based on that fact that each row of the tabular representation, one of the permutation variants in the field of G.
Thank you. Are there more questions? Thank you very much.